Okay, for a linear regression question, this is a typical sort of statement that we might see. We want to prove that it's true. Okay, so let's talk about the probability of y given x and theta. Okay, well, y is going to be the set of all of the targets. And x is going to be the set of all data vectors. Our model here that we're trying to use to generalize this data here is y is equal to yn is xn transpose theta, right? So the model here is y equals x theta plus some error, x transpose theta plus some error. So for each, at each line, yn is equal to xn transpose theta plus some error. And our errors, in this case, are going to be normally distributed with mean 0 and variance sigma squared. Our errors are independent, identically distributed. Okay, meaning that they there's no relation between errors, right? Each xn is independent, or each xn yn pair is independent, and they all come from some sort of normal. The errors come from some sort of normal distribution. Okay, so given that we know that, this is the probability then of y1, y2, yn given x1, x2, xn. Okay, because each of these are independent, the probability of y1 and y2 given x1 and x2 is the probability of y1 given x1 times the probability of y2 given x2 and theta. So this is going to be the probability of y1 given x1 and theta times probability of y2 given x2 and theta, so on, probability of yn given xn and theta, because they're independent. So then this should be the product n equals 1 to n of the probability of yn given xn and theta. Just writing it out in a more compact way. Now, of course, this is the probability of our targets given our data and our model parameters. We're not looking for that. We're looking for the negative log of the probability of our targets given our data and parameters. So then negative log of the probability of our targets given our data and parameters should be negative the log of that product of the probabilities of yn given xn and theta. Now here we've got the log of a product. And we know that the log of a product is the sum of the logs. So this should be negative the sum from 1 to n of the log of the probability of yn given xn and theta. And of course, that is exactly what we want to show up here. And so therefore, negative the log of the probability of our targets given our data and parameters is negative the sum from 1 to n of the log of the probability of yn given xn and theta.